All right, welcome to the video help and solutions for the trigonometry practice lesson, and this would also be a really good one to use to practice for the Chapter 5 test and even the Semester 2 final. First slide is just kind of checking in, anything you want me to know about. All right, slide 2 is some notes. These are the important triangle toolkits notes that we have so far. Basically, we have sine, cosine, and tangent. It works in right triangles. Sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, tangent is the opposite over the adjacent. We have the law of sines in the top right here. That works in any triangle. It does not have to be a right triangle, although it does also work in right triangles. It says that the sine of any angle divided by its opposite side is equal to the sine of any other angle divided by its opposite side, as long as they're in the same triangle. The other formulas that might come up are the Pythagorean Theorem, which is a squared plus b squared equals c squared. That's the legs of a right triangle squared and added together equal to the hypotenuse squared. Remember, the hypotenuse is always across from the 90. And then we have inverse trig, which is used in right triangles to figure out a missing angle. You have to know two of the sides. Uses the same ratios as sine, cosine, and tangent, but you press a different button on your calculator. You press the inverse button, and then you type in the fraction, and it gives you the angle. All right. Now we're going to solve some problems, and you have to figure out which is the correct formula to use. First one up here on slide 3 is this one. Now, I would say, first check, is it a right triangle? If it's not, you've got to use your law of sines. Law of sines, remember, says that the sine of an angle divided by its opposite side is equal to the sine of another angle divided by its opposite side. So pair up angles with their opposite sides. We've got sine 35 over 21 is equal to, and now we can pair it up the other way. We've got our x, we need to make sure we're getting that in there. It's opposite from that angle, so we're going to do sine of angle 65 is divided by x. Okay, that's what we've got. Now we need to solve this thing. How do you solve these? Well, one option that'll always work is cross multiplication. That would be sine 35 times x. Well, what's that? Well, that's x times sine 35. And then that would be equal to, well, it's going to be equal to the multiplying the other part of the cross multiplication here. That's going to be 21 times sine 65. Let's pop it open our calculator and find out what that is. 21 times sine 65. And that gets us 19.03 roughly. Close enough, 19.03. There we go. We're almost done. X isn't by itself. It's being multiplied by something. What's it being multiplied by? It's being multiplied by sine 35. That's just a number. Our calculator knows what that number is. Let's divide by sine 35 to get x by itself. All right, that's going to leave us with x is approximately equal to whatever 19.03. Oops, sorry, this thing's in tablet mode, so that's going to keep popping up. Hopefully that's not too annoying. 19.03 divided by sine 35. And that's about 33.18, I'll call it. I'm just rounding up. 33.18. Close enough. There we go. On to the next one. The next one, is it a right triangle? Nope, better use the law of sines. Here's our x, that's what we're trying to find. What's across from it? The 20. So we're going to do sine 20 with an x on the bottom equal to, remember, we're going to do the other angle and its opposite side. So it's going to be sine 35 over 8.3. From here, how do we solve it? Think to yourself first, do you know what to do? Hoping you're thinking cross multiply. X times sine 35 would be equal to whatever the 8.3 times sine 20 is. So we pop open the calculator again, and we go 8.3 times sine 20. That gets us about 2.8. I'm just going to round to one decimal place. About 2. Well, I'll use more. 83876. I'm going to call it 2.84. That 3 would round up because the number after it's a 5 or bigger, right? Okay, now we're going to get x by itself. We should remember from the last problem, x isn't by itself. Divide by the thing that's being multiplied with it. So let's divide by sine 35 here. And that's going to leave us with x equals whatever 2.84. 2.84 divided by sine 35 is. I forgot to write the 5 up there, didn't I? Well, we'll get that in a second. So the answer is about 4.95. Yeah, I forgot to get that sine in there. I guess we were out of space. Sine 35. All right, guys, moving on to the next one. Well, is it a right triangle? This time the answer is yes. If you wanted to, you could still use the law of sines here. But that formula is a little more complicated than our normal sine, cosine, and tangent formulas. Remember those? Sine, cosine, and tangent, you might have memorized it as SOHCAHTOA. Either way, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Popping on over here, we got to identify which side is which. From our angle, this side is the opposite side. Across from the 90 is going to be your hypotenuse. The last one left over is the side next to the angle that's not the hypotenuse, which we call the adjacent side. Now think through, what two sides are you using here? The side that you're trying to figure out, that's the opposite side. The side that you know, in this case, that's the hypotenuse. So if we think through our formulas, sine was opposite over hypotenuse, cosine was adjacent over hypotenuse, tangent was opposite over adjacent. Which formula is this going to be? The one that uses opposite and hypotenuse. That's sine. And again, you might have memorized this using SOHCAHTOA, this little memory trick I have down here. So this is going to be sine. So we're going to do sine. We do the angle, 78, is equal to the fraction. We have to get it in the right order, and it's in the order we have here, opposite on top, hypotenuse on the bottom. So it's going to be x on top, 18 on the bottom. From here, we need to solve. One method is put a 1 on the bottom and cross multiply. You're going to get 1 times x is x, and that is equal to 18 times sine 78, which we'll pop open our calculator for. 18 times sine 78. What do we get? Get about 17.6. Hey, our x is already by itself, so we are done. All right, once again, is it a right triangle? Yes, then we don't need to use the law of sines. Could we use the law of sines? Yes, but I'm going to do it the normal way. So we're going to label our sides. From here, the opposite side is over here. Across from the 90 would be our hypotenuse. And then the last one left over that is next to our angle but not the hypotenuse is the adjacent side. In this case, we're trying to find the adjacent side, and we know the hypotenuse. Think through our memorized trick, SOHCAHTOA. Which one are we doing here? We need adjacent and hypotenuse. That is going to be cosine. So our formula here is going to be cosine of the angle, in this case that is 25, is equal to a fraction with adjacent on top and hypotenuse on the bottom. That's going to be x on top and 4 on the bottom in this case. Put a 1 on the bottom here and cross multiply. 1 times x is x, and our answer is 4 times cosine 25. Let's type that in our calculator. 4 times cosine 25 comes out as about 3.63 because the 2 would round up. There we go. Let's move along to number 7. Hey, is it a right triangle? Yes, but wait, we're not trying to find a side. We're trying to find an angle. That's where we go back and look at our notes for inverse trig. Inverse trig uses the same fractions as our other stuff. Opposite and hypotenuse is sine, adjacent and hypotenuse is cosine, tangent is opposite and adjacent. But this time, you're going to use a different button on your calculator. The inverse button, you're going to type in the fraction. You have to know both of the sides, and it's going to tell you the angle. Let's take a look at this one. So from here, that's our opposite side. Across from the 90 must be our hypotenuse, which means that the 14 is the adjacent side. Opposite and adjacent, which one is that? Let's remember our formulas. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Hey, opposite and adjacent, this must be a tangent problem. But in this case, it's going to be inverse tangent. So you put that little -1 up there to stand for the word inverse. And we're going to go opposite on top. That's 7. Adjacent on the bottom, that's 14. We type that into the calculator, and it just gives us the answer. These ones are actually easier, as long as you know how to do it. On this particular calculator, you have to press the function menu to get all the functions where you'll have your inverse tangent. On other calculators, it'll work differently. Now, we've got to go back to the main menu to get our numbers again, and now we are going to do 7 divided by 14. That's coming out as about 26.565. And that would be in degrees. We just found an angle. So that is in degrees. All right, guys, that's that one. Let's move along. Hey, look, we're finding an angle again. It's still a right triangle. We're going to use the same exact kind of trick. Let's figure out which formula to use. That side's the opposite side. That side must be the hypotenuse. This one must be the adjacent. Adjacent and hypotenuse. If we do our SOHCAHTOA, So that's an H, by the way, right here. Toa. Which one uses adjacent hypotenuse? It must be cosine. So this is going to be cosine inverse because we're finding the angle, and we type in the two sides we know. In this case, it's adjacent on top, hypotenuse on the bottom. So 8 over 12, pop open our calculator. We're going to go cosine inverse. So I go to my function menu. I get my cosine inverse. And I pop back to the main menu to get my numbers. And we are going to do 8 divided by 12. And that comes out as about 48.18965. I'm going to round it to 48.2. Again, I didn't give you guys instructions on exactly how far to round, but always use at least one decimal place. And that is degrees. Remember, we were finding angles. All right, let's move along. Number 9. Hey, we're finding a side length. So it's not going to be inverse stuff. It's a right triangle, so we could use normal trig. But wait, we don't know any of the angles. So there's a couple ways you could approach this. One is you can actually use your inverse stuff to figure out one of the angles, and then you could do sine, cosine, and tangent. But there's a much more direct way to solve this. If you know two sides in a right triangle, you can find the other side using the Pythagorean theorem. What's the Pythagorean theorem? Let's go back to our notes. You first learned this back in middle school. A squared plus b squared equals c squared. That's in right triangles. The a and the b are the legs, the two sides that make the 90, and the c is the hypotenuse, the one across from the 90 degrees. Did my beautiful picture of myself just stop working? There we go. I fixed it, guys. Look at that. All right, let's keep moving. Here we were. So we're going to do a squared plus b squared equals c squared. So find the legs. Those are your a and your b, the two that make the 90. C is across from that. Okay, so that's going to be your a and your b, and this is going to be c. So we're going to do a squared plus b squared equals c squared, which in this case is going to be x squared. Ooh, writing all over the place, weird. Try that again. We're going to be doing x squared plus 5 squared equals 8 squared. All right, as far as solving Pythagorean theorem problems, first you should square the stuff and write down what you get. So we have x squared, which we can't really do because we don't know what x is. 5 squared would be 5 times 5. That is 25. That is equal to 8 squared, which means 8 times 8. That is going to be 64. Remember, it's not 16. It's not 8 times 2. It is 8 times 8. All right, now we want to get the x squared by itself. You can do that using subtraction. Subtract a 25 from both sides. So x squared is equal to 64 minus 25, which I could do in my head, but since I'm on a video, let's make sure I get it right. Use my calculator. That's going to be 39. Okay, now some people make the mistake of stopping here, but we need to get what is x. Undo squaring by square rooting, and that's going to leave you with x is approximately whatever the square root of 39 is. So I'm going to go square root, and we're going to go 39. That's going to be about 6.24499, blah, blah, blah. So let's call that about 6.245. Remember, I'm rounding up if the number after wherever I cut off is a 5 or bigger. Alrighty then, that's that. Moving on to the next one. Hey! We know two sides in a right triangle. We're trying to find the other one. This must be another Pythagorean theorem problem. So your a and your b are the two that make the 90. Your hypotenuse is c, the one across from the 90. So that means that we're going to do 4 squared plus 5 squared equals x squared. Again, square the stuff you can square. 4 squared is 4 times 4. That is 16. 5 squared is 5 times 5. That is 25. And that leaves us with x squared. Now, in this one, these are on the same side of the equal sign, so we can actually add them together. What is 16 plus 25? Well, 10 and 20 would get us 30. 6 and 5 gets us 11. So it's a 30 and an 11, which is a 41. All right, that is 41. It is equal to x squared, and don't forget that last little bit, which is to square root to get rid of the square. That's going to leave us with our final answer, which will be x is approximately whatever the square root of 41 is. So let's go square root of 41, and that's about 6.4. There's our answer. What's next? The screen where you say, how ready do you think you are to solve problems like these on a test, which we will have at the end of this chapter, and we are just about done with this chapter. Which types are easiest for you? Which are the hardest? All of that. Let me know if you have any questions, and have an excellent day.